law of equipartition of energy. Law of equipartition of energy. What is kinetic energy of a single molecule?
mv square
Half m
v square.
v square. In case of molecules, we take c square, na? Half m
Yes, sir.
c square. So the c can be resolved into three components x, y, z.
Mm,
So that means if c is the velocity resolved into three components, then I can say average kinetic energy in one axis will be half m cx square, half m cy square, half m cz square.
yes, sir.
एक मिनट ध्यान से देखना what is law of equipartition of energy. Then we will explain law of equipartition of energy using monatomic gas, diatomic gas, and polyatomic gas. The kinetic energy of a single molecule, comma, k dot e is half m cx square, or you can say vx, no problem, one and the same. Half m vy square plus half m vz square, assuming the velocity to be resolved into three components. So each direction will have half m vx square, half m vy square, half m vz square. Correct? Hello?
Yes, sir.
Now, for a gas at a temperature capital T, the average kinetic energy per molecule is 3 by 2. For a gas at a temperature T, average kinetic energy per molecule is 3 by 2 kBT. Last class we did. Kinetic energy one molecule is 3 by 2 kBT, if you are remembering.
Yes, sir.
So that means this 3 by 2 is like half plus half plus half will become 3 by 2.
Mm,
So that means each half mvx square or half mvb square vy square should be equal to half kBT.
yes, sir.
Then only half kBT, half kBT, half kBT will become 3 by 2 kBT.
Yes.
Okay, just write this much. Again, see what I did. Kinetic energy of single molecule is half m velocity along x square plus half m velocity along y. But we know that for a gas at temperature T, kinetic energy per molecule is 3 by 2 kBT. So I can assume that each half kBT is equivalent to each half m Vx square.
Mm,
तो इसको ही बोलते हैं कि जहां पे भी स्क्वायर टर्म आया वहां पे हाफ kBT एनर्जी डिवाइड हो जाएगा. पार्टीशन मतलब डिवीजन ना.
yes, sir.
3/2 को हमने तीन पार्ट में डिवाइड कर दिया. हाफ kBT plus half kBT plus half kBT. So altogether it became 3/2 kBT. Right, write this one, then I'm explaining further. Kinetic energy of single molecule K dot E is half mvx square plus half mvy square plus half mvz square. For a gas at temperature T, the average kinetic energy per molecule is written as 3 by 2 kBT.
Done, sir.
Okay. Thus, half mvx square is half mvy square is half mvz square. Average of each molecule along x direction is same as along y is same as along z, which is half kBt. So we can say hence the mean energy associated, see I wrote half, not 3, लेकिन सबको ऐड कर देंगे तो 3/2 हो जाएगा. Hence the mean energy associated with every component of translational kinetic energy, which is quadratic in the velocity components in x comma y comma z direction is half kBt. Thus total kinetic energy is 3 by 2 kBt. Total kinetic energy is 3 by 2 kBt for a molecule. This is known as law of equipartition of energy. That means each velocity square term is half kBt, is known as law of equipartition of energy. Understood what we wrote? Hello? Hello? Hello?
Yes, sir.
Hello?
Yes,
Yes,
sir.
sir.
The total energy is 3 by 2 kBt, which is nothing but divided into three parts. Half kBt along x, half kBt along y, half kBt along z. So because it is equally divided, it is called as law of equipartition of energy. So each velocity square term is equivalent to half kBt. Now complete full. Yes, can I clear this now?
Yes, sir.
So actually speaking, law of equipartition of energy is nothing but energy is equally distributed in each component along x half kbt, along y half kbt, along z half kbt. Explain law of equipartition of energy with the help of degree of freedom. What is monoatomic gas? They can exist freely into single molecule. That is called mono. If exist freely with two molecules together, then diatomic. If exist freely with more than two, then it is called polyatomic. Consider monoatomic gas such as an example of monoatomic gas. Hello?
Hydrogen.
Hydrogen can stay singly.
No, it will become unstable then.
Noble gases.
Noble gases such as what?
Helium.
Helium, argon, neon.
Helium, argon, that we can take now.
Yes, sir.
Yes, sir.
So monoatomic, consider monoatomic gas such as helium, argon. They can move in space, correct? That means they can move along x-axis also, y-axis also, z-axis also. So
Yes,
consider
sir.
atomic gas such as helium, argon, they can move in space. Hence, they have free degree of freedom due to translational motion. Thus, average kinetic energy will be 3 by 2 kbt because each axis half kbt. So it has got total energy 3 by 2 kbt due to translation motion. Copy this much. So monoatomic gas, single molecule can move in space in any direction. Therefore, it has got 3 degree of freedom due to translation motion. Hence, its energy is 3 by 2 kBT. Once you are done, please tell. Then we'll see diatomic rigid, diatomic non-rigid, then polyatomic. I think completed.
Yes, sir. Done.
Okay. What is meaning of rigid and what is meaning of non-rigid?
Sir, rigid is basically it has a fixed shape and size and cannot be and its shape cannot be changed by external forces. And a non-rigid body does have a shape, but it can be changed by the external forces.
That means they can vibrate.
Yes, sir.
Okay. So consider diatomic rigid gas such as oxygen, nitrogen, etc. That means they will not move singly, they will be two atoms together. So they can translate in all direction. Correct, no?
Yes, sir.
Is it that oxygen can move only along X? It can move in all direction. Hence, they have 3 degrees of freedom due to translational motion. Due to translation motion. Now, since they will be always two molecules together, two atoms, so there will be some force of attraction between them. So sometimes they can rotate. Hello?
Yes, sir.
If it rotates about this axis, then due to rotational motion, it will have rotational kinetic energy, which is half I omega square.
Yes, sir.
If I rotate this along z axis, then also it will have rotational kinetic energy.
Hmm.
But along x axis, when you rotate, that means two molecules are on axis. When you rotate axis, what will be its moment of inertia? Will it be zero? Because they are on the axis.
Yes.
So what will be rotational kinetic energy? Zero.
Yes.
See, again, understand what I'm saying. Suppose I take pencil, उसके ऊपर ही दो molecule है. ये pencil को घुमाऊं वही जगह पे, तो rotational kinetic energy will be zero, no?
Hmm.
Because their distance from axis of rotation is zero.
Yes, sir.
So these two molecules, if you rotate along y-axis, then they are situated at certain distance from y-axis. So that will give rotational kinetic energy. If I rotate about z-axis, then molecules are situated at certain distance from z-axis. But if I take x-axis, तो x-axis के ऊपर ही है ना ये.
Yes, sir.
So that means they will have translation motion 3, but rotational motion only 2, because third वाले का moment of inertia 0 हो जाएगा.
Hmm.
So if we consider diatomic rigid gas molecules such as oxygen, nitrogen, hydrogen, they can translate and give 3 degrees of freedom. They can rotate and give 2 degrees of freedom due to rotational motion. They can translate in all direction, hence 3 degrees of freedom. They can also rotate and produce rotational kinetic energy. Thus, they have 2 degrees of freedom due to rotational motion. Due to rotational motion. Thus, total energy is sum of translational and rotational kinetic energy. Therefore, E is translation plus rotational. So E will be 3 by 2 kBt plus 2 into half of kBt. That means again you are getting 3 degree of freedom. So 3 into half, 2 degree of freedom, 2 into half kBt. So each energy or each degree of freedom is equivalent to half kBt. Hello?
Yes, sir.
This is showing that depending upon degree of freedom, their energy is multiplied. So it is equally divided. One direction, half, two direction, two into half, three direction, three into half. So 3 into half, 3 by 2 due to translation, 2 into half, that is nothing but 2 into half kBt due to rotational kinetic energy. So every square term is equal to half kBt. Okay?
Yes, sir.
Okay, copy this much. Consider diatomic rigid gas such as oxygen, nitrogen, etc. They can translate in all direction. Hence, they have 3 degree of freedom due to translation motion. They can also rotate and produce rotational kinetic energy. Thus, they have 2 degree of freedom due to rotational motion. So, total energy is sum of translation and rotational. If done, then say please.
Done, sir.
Consider diatomic non-rigid gas such as carbon monoxide CO. This gas, in addition to translational motion, comma, rotational motion, also has vibrational motion. The energy due to vibrational motion, comma, E in bracket vibrational. Vibration means oscillation.
Yes.
So it has got kinetic energy plus potential energy.
Yes, sir.
So half mv square plus potential energy, if you remember, it is half k x square. Oscillation mean half m omega square x square. This is k. Hello.
Yes, sir.
So I can say half k y square because it is vibrating along y. So how many square term you have? One square term or two square term?
Sir, one square term.
How? This is one and this is one, two, no?
Oh, sorry, two.
So if it is translation, then it had only one square term for one motion. Rotational, one square term for one motion. But one vibration has got two square term. So if I consider diatomic non-rigid gas, it will have energy due to translation, due to rotational, and due to vibrational. Okay,
Yes, sir.
this energy will be 2 times half kBT because of two square term. Hello.
Yes, sir.
Yes.
So can I say thus total energy due to 3 degree of freedom, total energy due to 3 degree of freedom, total energy due to 3 degree of freedom due to translational motion. Okay, थोड़ा सा इजी करता हूँ. This energy will be 2 times half of kBT. Just copy this, then I'm clearing the space. To find what is total energy. 3 degree of freedom due to translation, 2 due to rotational, 1 due to vibrational. But vibrational has 2 square term. Completed.
Yes, sir.
Done, sir.
Okay. Thus diatomic non-rigid gas has 3 degree of freedom due to translational motion and 2 degree of freedom due to rotational motion and 1 degree of freedom due to vibrational motion. Therefore, total energy equals to 3 into half kBt plus 2 into half kBt plus 2 into half kBt. Because in vibrational motion, there are two square terms, so 2 into half. This three lines, three terms clear? 3 into half, 2 into half, 2 into half.
Yes, sir.
Okay. Why 2 into half? Because in vibrational motion, there are kinetic as well as potential energy. Thus, law of, now if they say explain law of equipartition of energy, then this whole thing you will write. If only define that first paragraph which I gave at the start, that you will write. So I can say thus law of equipartition of energy is stated as, in case they say explain तो ये पूरा, otherwise वही खाली first line बस उतना ही, stated as for a gas in thermal equilibrium, for a gas in thermal equilibrium at temperature capital T, the average energy associated for average energy associated for each quadratic term is half kBt. Khatam. For a gas in thermal equilibrium, average energy associated for each quadratic term is half kBt. Clear? Hello?
Yes, sir.
Yes, sir.
Meaning followed no? Each motion is
Yes, sir.
half kBt. This is called law of equipartition of energy. Complete full.
Done, sir.
Next to the specific heat capacity. Specific heat capacity. Suppose this is one solid. I insert thermometer in this. How much it will record?
Sir, it will record up to its limit, that is 100 degrees Celsius, if it is a Celsius thermometer.
No, no. Suppose in a room, I have one solid. I insert thermometer. At that instant, what it will record?
Room temperature?
Room temperature. Suppose it is recording, for example, room temperature. I am assuming room temperature to be 20 degrees Celsius. AC लगा के रखा है room में. Now when I supply heat to this, will its temperature rise? At certain heat, it may become 21. No?
Yes, sir.
So how much is the change?
1 degree.
1 degree Celsius. So whatever heat you have given to increase its temperature by 1 degree to this entire mass is called actually heat capacity. But we are talking about what? Specific. Specific means for 1 kg. So suppose we take 1 kg of substance and increase its temperature by 1 degree Celsius. Increase means difference in temperature. Then that time whatever heat you have supplied is called as specific heat capacity. पूरे मास के लिए heat capacity, 1 किलो के लिए specific heat capacity. So amount of heat required to raise the temperature of unit mass of substance by 1 degree Celsius or 1 Kelvin is called as specific heat capacity. Just listen what is specific heat capacity one second. पूरे मास के लिए जो हीट देते हैं उसको क्या बोलते हैं हम लोग? Heat capacity.
Heat capacity.
Yes, sir.
Remember heat or sometimes thermal capacity, but specific is for 1 kg. So I'm defining like this: the amount of heat required to raise the temperature, the amount of heat required to raise the temperature of unit mass of substance by 1 degree Celsius or 1 Kelvin. The amount of heat required to raise the temperature of unit mass of substance by 1 degree Celsius or 1 degree Kelvin is called as specific heat capacity. Let S be the specific heat capacity. So can you tell me what will be heat required to raise the temperature of mkg of substance by same 1 degree Celsius or 1 Kelvin? S is for 1 kg, changing the temperature by 1 degree. So for 2 degree it will 2 kg it will be what? 2s.
Yes.
3 kg 3s. mkg ms.
Yes, sir.
And if temperature is changed by 2 degree, then ms into 2, 3 degree ms into 3, and theta degree, then ms into theta. Not followed?
Followed, sir.
So if S is the specific heat capacity and M is total mass, specific heat capacity, let S be the specific heat capacity and M be the mass of substance whose temperature is changed by theta Kelvin or theta degree Celsius. Therefore, heat supplied Q will be mass into specific heat into change in temperature. Clear this much?
Yes, sir.
Please copy till this. Amount of heat required to raise the temperature of unit mass of substance by 1 degree Celsius or 1 Kelvin is called as specific heat capacity. Let S be the specific heat capacity and M be the mass of substance whose temperature is changed by theta Kelvin or theta degree Celsius. Then total heat supplied Q is mass into specific heat into change in temperature.
Done, sir.
Okay. Mass into specific heat into change in temperature is total heat. Therefore, specific heat will be Q upon M into theta. So what will be its SI unit from this? Can I say
Joule per Kelvin.
Joule per kg Kelvin? What will be its dimension? Dimension? Joule means M1, L2, T minus 2, correct? Joule means
Yes, sir.
energy, energy means work. Upon kg is M1, Kelvin K1. So can I say M0, L2, T minus 2, K minus 1?
Yes, sir.
Right. 3 more lines write down. During exam you all want holiday or we can have the revision lectures? No new chapter, only revisions? Hello?
Yes, sir.
See, your exams are starting from March, correct?
Yes, sir.
So you want me to give holiday, or I can keep this 3 days revision lecture?
Sir, you keep 3 days revision lecture because we have a first paper physics.
So it's okay na if I keep
Yes,
revisions
sir.
on Monday, Wednesday, Friday, है ना?
Yes, sir.
Yes, sir.
ठीक. Moment you feel के नहीं, we have to prepare, tell me, and nothing will happen. Hardly we sit for 1 hour. So revision will be beneficial. Completed this much?
Yes, sir.
Okay, okay. In case of gas, there are always 4 variables. What is this P called as?
Pressure.
Pressure. If I keep pressure constant, then it is called isochoric process.
Yes, sir.
No, isobaric process. Isobaric, okay? Isobaric. If volume is kept constant, then isochoric.
Yes, sir.
And temperature kept constant, then
Isothermal.
isothermal. If heat kept constant, then
Adiabatic.
adiabatic. So there can be isobaric process, isothermal process, isochoric process, adiabatic process. Gas can be heated in any one process. So one question is, why in case of gas there is two specific heat? Why there is need to define two specific heats in case of gases? Why there is need to define two specific heats in case of gas? Since specific heat is Q upon m theta. So if gas is heated adiabatically, what is meaning of adiabatically?
Sir, temperature is kept constant.
No, heat is kept.
Heat is kept constant, yeah.
If heat is kept constant means you have not taken any heat, neither you have given any heat, no?
Yes, sir.
And this Q means heat supplied. Hello?
Yes, sir.
This Q is what? Heat supplied, na?
Hmm.
In adiabatic, we neither supply nor we take. So can I say if gas is heated adiabatically, then Q should be 0?
Hmm.
So our specific heat capacity is 0 upon m theta. What is 0 upon anything? Zero. Yes, zero. So when gas is heated adiabatically, then we got by formula there is no specific heat capacity. That means no need to supply heat. वो अपने आप adjust कर लेता है. Please copy this much. Okay, completed.
Yes, sir.
Yes, sir.
Now, if heated adiabatically, then we got specific heat capacity should be zero. If heated isothermally, then theta is zero because no change in temperature. So therefore S will be Q upon M into zero. So Q upon zero. Anything upon zero is what? Infinity.
Yes,
मतलब जीरो से लेके इंफिनिटी तक वैल्यू हो सकता है ना गैस को हीट करने के लिए.
yes, sir.
मतलब अगर एडियाबेटिक किया तो जीरो आया, आइसोथर्मल किया इंफिनिटी, इसके बीच में इनफाइनाइट वैल्यू हो सकते हैं ना, मतलब चांसेस.
Yes,
कैन आई रिमेंबर ऑल इनफाइनाइट वैल्यूज? Nobody
no,
can
no.
remember. So thus there can be infinite values of specific heat in case of gases. Hence, to have two specific heat. Hence, to have two specific heats, gas must be heated either at constant pressure or at constant volume. नहीं तो infinite value हो जाएगा. So to have two definite values, the gas is heated either at constant pressure or at constant volume. Okay, you followed this meaning?
Yes, sir.
See, there were four possibilities. Adiabatic zero, isothermal zero. अभी दो ही बचता है ना, या तो constant pressure या तो constant volume. अगर ये दो छोड़ दिया तो infinite values आ जाएंगे. So write further. If heated isothermally, then theta is zero.
Done, sir.
So next we'll proceed in the next class, that is tomorrow. Within this week we will complete everything.